grab out a pen or pencil. Let's write a couple of notes. Pretty straightforward. Year 12, last session you would have practiced a bit on the first two content. So moving from fractions to decimals, how do you go to percentages times 100? How do you go the other way around? Percentages to fraction decimals, divide 100. Yeah, only two skills. Let's do the first one. Example 1. Express as a percentage. So Dimmy scored 12 out of 20 for their test on percentages. What is Dimmy's score as a percentage? Let's test the year 11s because you guys would have done this already quite a bit. 12 out of 20. That's 12 out of 20 right there. How do I convert 12 out of 20 into a percentage? Can I please have, let's go with Michael, what do you do? Beautiful, times 100 because you need to convert it to percentages. And we can see right here, times by 100. On your calculator, what would you be typing? Can I please have Estella? What would you type? Beautiful, 12 divided by 20 times 100. Excellent. You can use a calculator at this point, or if you already know, that's out of 20. You just need 5 more to make 100. So if you times 12 by 5, you get 60. So you should be 60%. Fill that in, thank you. Year 12s. Make sure to copy the notes in. Okay, so just teaching you how to convert it into your calculator. Example 2. Let's pick a year 12 now. Shh. Thanks, boys. Let's not speak while I'm speaking. Thanks. Example 2, it says calculate percentages. So this is where now you're applying your percentages. 15%. That's the same thing as writing what. Can I please have, let's go Finita. When you say 15%, what is that really the same thing as saying? It's 15 out of 100. Very good. That's what percent means. It's every 100. Then the next one, some students don't know. Of is an operation. Is it add, subtract, multiply, or divide? Jasper. Of. Is that add, subtract, multiply, or divide? That's what most students think. When we say half of 10, we think of 10 divided 2. That's what we think. But the mathematics to it has to be times, because 10 over 1, when you times it, it's 1 times 10 is 10, and then 2 times 1 is 2. Then it ends up being 10 divided by 2. So a lot of students think the word of means divide. It doesn't. So if you weren't sure there, can you please write this down? Of means times. And you're multiplying to 140. So how do you work this out on a calculator when they say find 15% of 40? You literally do what we just read. 15% is 15 divided 100. Of means times 140. So on your calculator, you literally type 15 divided 100 times 140 to work out what 15% of 140 is. Here we go. I'm going to do it on a calculator so you can see. Here's a calculator. 15 divided by 100 times 140. And you get 21. So the answer is 21. So if they said 15% of 140, you should expect it's $21 or 21 people. That's what the 21 represents. Let's do a word problem together. Example 3. Here's a word problem. Increase or decrease. Let's go back to the 11s. Here we go. An online retailer has a 30% off. So you're taking 30% off at the end of a year sale. If a jacket you want to purchase online is priced at $123, how much will you pay with a discount? Here we go. Let's start off with Mitchell. So we want to find 30% off. So we need to find what 30% of 123 is. What's 30% mean? 30 over 100. Very good. What does of mean on this side? Let's go with Josh. What does of? What does that mean? Times. Very good. So this means 30 over 100 times, and we're looking at 123. So we're looking for 30% off the overall amount. So we need to know what 30% is as a value. So 30 divided by 100. So type that on your calculator. 30 divided by 100. times by 123. And that should give you your answer. So let's try it on a calculator here. 30 divided by 100 times 123. So you're taking off $36.90. $36.90 is what 30% is. So when they ask, how much will you pay? Well, you're not paying $36.90. You're removing that. The original cost was $123. But you're going to remove 30%. 30% is $36.90. So to remove, you minus $36.90. And on your calculator, 123 take away 36.90, you should get your answer. 123 minus 36.90, you get $86.10. Now this is one way of solving it. There is a faster way, and this is the way I normally do it. And I prefer that you guys learn this method, but I understand most students do it this way. Is this okay? There is a faster way. Here's the faster way. So I'm going to show you a faster method with a calculator. Because you already know that 123 is 100% of itself, which is the original price. If you have 30% off, that means you're losing 30%. You're not paying 100%, you're paying 30% less. So this is what it looks like visually. If $123 is 100%, but you're only paying 30% less. If you drop it down by 30%, how much are you truly paying of the original amount? 70%. So it was a lot faster. Instead of calculating 30% first and then subtract it, you can just do 70% of 123 and you'll get your answer. So if you literally just worked out what 70%, which is already a 30% reduction, 70% of 123 will give you exactly the same answer with just one shot. So on your calculator, all you had to type was 70 over 100 of means times 123. So 70 divided 100 times 123. You would have got your answer. You didn't have to do this two-stepper. You don't have to do 30% of it to find out what 30% is and then subtract from the original. You could have done it all in one go and just went, what's 70% of 123? Because that's what I'm paying. So if I do it on the calculator to show you, 70 divided by 100 times 123. So that you get exactly the same, $86.10. And that's a lot quicker. That's how, generally, if you ever, one day when you go to get a bank loan, watch the people when they're typing it in. I like watching it because I want to see what they're thinking in their mathematics. Those people that calculate your loans, they do the percentages. And in front of you, you'll see when they do 70% or 10% reduction or 10% increase, they will type those numbers on the calculator. And that's essentially how we do things faster. We don't do it like this. Okay? Most students will do it this way because it makes more sense to them. To me, if you get this bit, that's a lot quicker. Okay, so try to learn that way. That's how people generally do it. Okay. All right. That's pretty much most of what the year 11s need to know for 8.2. For year 12s, there is one last bit that adds on for the exam. They need to know percentage errors. Okay? Sounds fancy, but it's not. It's pretty much what you guys did in the last session about percentage change. They just changed the name. So the formula for your percentage change is exactly the same as the percentage error. They just give a different name to it. Okay? So, what is percentage error? Percentage error for the 12s, that's just the error that I've made based on my estimate versus what reality is. Whatever that difference is, convert it to a percentage. That's all it is. Yeah, so here's an example. That's why I wrote here, note, it's always positive, because they don't care about whether it's negative or positive. They just care about how much percentage of an error is it. Let's do an example. Turn over the page. Over the page, example 4. Let's say, end of year, I predicted one of the students in this class, and I said you would get a study score of 30. So I made a prediction you're going to get 34 foundation maths. But then you actually got 42, right? The question is, what is the percentage error? So I made an error in my guess already. I guessed you're getting 30, you got 42. I made an error. But what is that as a percentage? So here, let's work out my error. How much of an error have I made? 12. Very good. Now, in the formula, it's what I guessed minus what you actually got. So I guess you get 30, but you actually got 42. So what kind of error did I make? 30 minus 42. It is 12, but it's negative 12 because I underestimated you. So the negative means underestimation, right? Now we want to find percentage error. The formula I just gave to you, percentage error, is equal to estimated, which is 30, minus what you actually got, over, and you can see here I wrote actual, so you got actually 42 times my 100, because that's what you actually got. So out of 42, I was 12 off. Yeah, so here, your answer will look like this. 12 under divided by 42 times 100. But notice that negative. At year 12 level, we don't need the negatives. Okay, keep it all positive. So your answer should just be 12 divided by 42. So here we go. Type it in. 12 divide 42 times 100. 12 divided by 42 times 100. And you get 28.57. It says round to one decimal point. So it should be 28.6. Copy that down. See, I know it says negative there. Your final answer, don't put a negative. Okay, so percentage errors don't have negatives, but that's no different from your percentage change for the year 11s. So 11s do percentage change, year 12s do it, they call it percentage error. Okay? And then I just checked in a 2024 exam question that you can try. That is an example that I think at the start of the year, some of you tried and some of you didn't get what percentage error was. You should be able to do it now. So that was one of the multiple choice questions we gave to you. So here's the example. See if you can work it out. Company estimates the total cost of purchasing equipment to be $24,000. So they guessed $24,000, but the actual cost ended up being $25,920. Work out the percentage error. Okay, so that was one of the questions I gave to you either during orientation or one of your booklets. Okay, but that's it. That's 3.3. So year 12s, you need to know how to apply percentages and then work out percentage error. You guys on this side, you're mainly working on percentage and then percentage change. Okay, that's a slight difference. Cool?